All right, let's try again. So, number one, please cross out the answer choices and then read the problem to yourself. Okay, I need you to circle where it says theoretical probability because that means you are using the spinner and not the data. It's looking for orange, so you're going to put the number of orange sections on top of the total and then simplify if you can. Go ahead and pause, do that, raise your hand if you have any questions. All right, next one. It says that we are doing experimental probability, which means we are only using the data table. On top, you're going to put the number of times we landed on orange over the total, which can be found in the problem. So go back and read it, pause and solve and simplify if you need to. All right, next it says you've decided you want a plant for your room. At the gardening store, there are 4 different kinds of plants: tulips, ferns, cactus, and ficus. There are 4 different kinds of pots: clay, plastic, metal, and wood. If you randomly pick a plant in a pot, what's the probability you'll end up with a tulip in a plastic pot? Okay, so when you have multiple probabilities, you're going to multiply. First is the probability of getting a tulip is 1 out of 4, and then getting a plastic pot is 1 out of 4 as well. Go ahead and multiply across. All right, Justin lives in St. Paul and goes to school in Minneapolis. In the morning, he has 3 transportation options: bus, cab, or train. In the evening, he has the same 3. Okay, so what's the probability that he'll use the bus first and then the train? So you need to set up 2 separate probabilities. What's the probability of taking the bus? Should be 1 out of 3. And the train should be the same. When you have multiple probabilities, you should multiply straight across. All right, next it says a major department store mailed 1,500 postcards offering a 25% discount on any single item. They predict 45% of the coupons will be used at the store. How many people will shop and save based on this prediction? Okay, so prediction means to set up a proportion. So go ahead and do that. Now we need to go back and identify what's important and what's not. So first of all, it says percent, 45% will be used. So you need to go ahead and plug that in. Percents always go above 100, okay? Now it says 25% is the discount amount. We don't actually care how much the discount is, so we're gonna cross that out and ignore it. You need to plug in your total and your X. Then you're gonna cross multiply and divide. Pause and solve. Okay, next one. It says, what's the percent? What percent is a reasonable estimate of the probability that the next Tucker family vacation lasts less than 3 days? So what you're going to do is in your data, you're going to go and circle all the numbers less than 3. That's your number for top. The bottom number is always your total. And we're asking for a percentage. So what you're going to do is you're going to set up a percent proportion. Okay, so your X is going to go where the percent goes. The 100 always goes underneath the percent. Go ahead and pause and solve. All right, Joanna will roll a fair number cube 90 times. The number cube is the same thing as a regular dice. How many times can she expect? Expect means prediction. Prediction means proportion. How many times can she expect to roll a number greater than or equal to 5? So I'm going to write down all the numbers that are on the number cube or the dice. Circle the ones greater than or equal to 5. That's my number for top. My total is the total number of numbers on a dice, which is always 6. And then I need to plug in my new total and my X. Okay, don't forget when you have proportions, you're going to cross multiply and then divide by the number left over. Okay, pause and solve. All right, next. Mildred has a bag of coins. It contains 10 dimes, 5 nickels, 1 penny. My total is 16. She will randomly select 2 coins from the bag without replacement. Circle without replacement and super important. If I am picking out 2 different things, okay, I'm picking out a dime first and then a penny. When I pick out my dime, my total is still 16. However, after I take my dime out and I do not replace it, my total turns to 15. Okay, how many dimes are there? 10. How many pennies are there? 1. You can either simplify first and then multiply straight across, or multiply straight across and then simplify. Guys, y'all can skip number 10. All right. Number 9 says Miss McFadden chooses a marble at random and then replaces it. She selects a second marble at random. Okay. The important thing here is that she is replacing it. So my total in these two separate probabilities are going to stay the same. Okay. All right. So my total is going to stay the same. So let's count up my total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm looking for striped ones both times. So count how many striped ones are. That's going to be the number on top. When you have multiple probabilities, you need to multiply. You can simplify first and then multiply, or you can multiply and then simplify. Okay, go ahead and pause and solve.